Hey, Algebra 2, today we're going to talk about changing the amplitude and period. We're going to change the amplitude and period of the sine and cosine functions, and then we're going to graph them. Well, on our last section, we had y is equal to cosine theta. That's really what we dealt with. But now what we're going to do is we're going to throw a couple more numbers here. Notice here, it says graph 2 cosine pi plus 4. Well, this number up front has to do with the amplitude. There's a format. I'm going to write out the format here. It looks like y is equal to a cosine of b theta plus c. Okay? In which a is going to be the amplitude. Okay? But really we're going to take the absolute value of a. Okay? The amplitude, basically, if my regular cosine looks like this, if I have an amplitude of 2, it doubles the height of it. So it ends up looking like that. That's a really ugly sketch, but we'll make it look a lot better when we do our problem here. Now, b helps us find the period. Now, one period is equal to 2 pi over b. Okay? So that means when we do the cosine wave, from here, the distance from here to here, so one full cycle, that is what we call one period. Okay, so we need, on some of these problems, we're going to have to change the period in order to see how long one cycle takes. And lastly, for this case, for today, we're going to do C. This is called the vertical shift. And what that does is takes our regular cosine wave, and if I had y equals cosine theta plus 1, it would shift it up. Excuse me. So let's go ahead and apply these. Let me go ahead and erase that. Alright, so it says graph y equals 2 cosine theta plus 4. The first thing you always want to do on these is find the period. And again, one period is equal to 2 pi over b. And again, b in this case is the number in front of theta, which in this case it's an invisible 1. So for this problem, it's 2 pi over 1, which is just 2 pi. So whenever you don't have a number in front, there's an invisible 1, it means the period is the same. It's just 2 pi. So what you should do is just make any mark somewhere out near the end of your x-axis and label that 2 pi. That's one full cycle. And what we're going to do is halfway, remember in our last lesson I said there's those 4 intervals that we're going to work with. Well, halfway between 0 and 2 pi is 1 pi. Now halfway between 0 and pi is pi over 2. And notice we have 1 pi over 2, 2 pi over 2, and this one's going to be 3 pi over 2. And this one is 4 pi over 2, just reduced. Sorry, I got a little bit of the sniffles. Alright. So we did one period. We make our marks. What we're going to do first, this is what I want to do first. First, in red, we're going to graph the original y equals cosine theta. So therefore we can see in black what changes are going to be made. So I'm going to make some marks here. Let's go 1, 2, 3, 4, 5, and we extend this a little more, 6, and we're going to work our way back down here too. So 1, 2, 3, 4, 5, 6. Okay? Now, the regular cosine wave. Again, I'm going to do it in red. We said starts at 1. Okay, starts at 1. Halfway through it's at 0. Or sorry, the first interval, a fourth of the way through it's at 0. Then it's down at -1 at pi. It's back up to 0 and then back up to 1 to end it. I know this is a much smaller graph than we did in the last section, but it's because we're going to have to actually stretch this and move this. So if you look in our last graph, this is what cosine wave looked like. Well, that's what this is. It's just we squeezed it down. Okay. So this is what our original cosine wave. So what we're going to do is apply the amplitude and the vertical shift. We're going to do that in black. So the first question, this is how we're going to do it. We're going to take these 1, 2, 3, 4, 5 dots, and we're going to apply these numbers to them. So if the cosine were to be 0, where it starts at 0, what would you get? If you plugged in 0 for cosine theta, you get 2 times 0, which is 0, plus 4, which is 4. So now, instead of starting at 1, I totally messed that up, I'm sorry. Let me redo that. If you plug in cosine 0, you get 1. This is where you start. You start at 1. You get 2 plus 4, which is 6. So it's up at 6. That's where it starts. Instead of starting at 1, starting at 6. Now, for this one, where is this y value? At our first interval, the y value is at 0. So 2 times 0 plus 4. That's what I meant to do. So that's 0 plus 4, which is 4. So now, instead of being at 0, it's up at 4. Now let's go to our next interval. This one's down at negative 1. Notice it's down at negative 1. If I plug negative 1 in for cosine theta, I get 2 times negative 1 is negative 2, plus 4, which is positive 2. So now this, instead of being at negative 1, now it's up at positive 2. Okay. And now we have this y value is at 0. So again, 2 times 0 plus 4. So that's 0 plus 4, which is 4. So now this is up at 4. And lastly, let me move that over. Actually, no. So our last one, notice it's up at 1. So now we're going to apply our amplitude and vertical shift. So instead of being at 1, so the cosine of 2 pi is 1. 2 times 1 is 2 plus 4, which is 6. So now this is back up at 6. So notice here, if I were to draw the wave, see the distance from the top of this wave to the bottom of that one, that distance is 2, negative 1 to 1. The distance of this one, though, from the top to bottom, it goes from 2 to 6, which is 4. So notice, that's where the amplitude comes in. Here, it was 2, but now we doubled it to make it 4. That's what that 2 is all about. That distance of 2 has now become a distance of 4 because of our amplitude. But now we put the 4, that means we've taken this graph after stretching it 2, and then we just moved it up 4. That's what the vertical shift is all about. Okay? Let's do one more of these. Y is equal to negative 3 sine of 1/2 theta minus 1. So now we have all 3 numbers here that we need to figure out. Well, our amplitude, if I had to state my amplitude, some of these problems you're going to have to do that. I say my amplitude is equal to 3. Remember, it's the absolute value of whatever number's out in front. So that means instead of having a difference of 2, remember from top to bottom of the sine wave, oops, this distance was 2 on our original function. Now, because of that amplitude of 3, we're going to multiply that by 3. So there should be a distance of 6 from top to bottom after we graph this, okay? So again, when it comes to graphing, I said in our last example, you always want to find your period. So in this case, 1 period is equal to 2 pi over b. B is whatever number's in front of theta, so 2 pi over 1/2. But notice, now we have 2 pi over 1/2. Whenever you have a fraction in the denominator, it swings up to the top. So this becomes 4 pi. So when I make my mark out here, instead of it being 2 pi, it now becomes 4 pi. So halfway between 0 and 4 pi would be 2 pi. Halfway between that would be 1 pi. And our third interval would be 3 pi. 1 pi, 2 pi, 3 pi, 4 pi. Okay? So again, I know on this one it was pi over 2 pi, 3 pi over 2, 2 pi. But this 1/2 here changes our period. Okay? Now we're going to make our marks here. So 1, 2, 3, 4. Actually, I'm going to redo those. Yeah, stretch them out a little bit further. 1, 2, 3, 4. Alrighty. So now, I'm going to graph our original sine wave. Our original sine wave we'll do in red. So sine starts at 0. Actually, let me label so you guys know what's going on. 3, 4, -1, -2, -3. Alright, so our original sine wave starts in the middle of the period, and at the end of the period it's at 0. And at the first interval it's up at 1, and at the third interval it's down at -1. This is our normal sine wave. Okay? When it comes to intervals, after the first interval it's up at 1, second interval it's at 0, third interval it's at -1, at the end of our fourth interval it's at 0 again. So now we're going to apply these numbers. Okay? Well, when we graph this, we've already dealt with the 1/2, so don't even worry about the 1/2 anymore. Okay? So now we ask ourselves, at our first starting point, it starts at 0. So -3 times 0 minus 1. Because again, we're plugging 0 in place of sine of 1/2 theta. So this gives us 0 minus 1, which is -1. So now it starts at -1. Now the thing about sine, which is going to save you a lot of time if you memorize this, is that sine, it begins, middle, and end all at the same y value. So I know if this is at -1, halfway through it's at -1, all the way through. At the end it's -1. Okay? So now we need to find these two values. Well, this one, after our first interval, it's up at 1. So -3 times 1 minus 1. So that gives me -3 minus 1, which is -4. So now this is going to be down at -4 at our first interval. Alright? And we already found our middle interval. We know it's at -1. So our third one is usually at -1. So we're going to plug in -3 times -1 minus 1. So it's 3 minus 1, which is 2. So instead of being at -1, now it's up at 2. So here, if I were to connect the dots, here goes my sine wave. Okay? And there we go. Now notice it's upside down. So when we did our last one, here's our sine wave. It went up and then down, then back up. So you know that if there's a negative out in front, let me get all this stuff out of the way. If you know there's a negative out in front, we know that it's going to be reflected. Okay, it's going to be upside down. But notice here, like I said about the amplitude, the distance from here all the way to here, so 2 down to -4 is 6, because an amplitude of 3. Okay, it doubled our original range. Alright, so this is how we apply. First, always graph the period, 2 pi over 1/2, so that became 4 pi. You make your first mark, label it 4 pi, cut in half, 2 pi, cut that in half, 1 pi, times that by 3, 3 pi. And then we have to apply our amplitude and vertical shift. We are going to get a lot more practice, so if you're still confused after this video, it's okay. We're going to get more practice in class and for homework. So good luck with that. I hope that made somewhat sense, and we will work on this more. Alright, see you later.